Hey guys, we're here working on Unit 2.3, 2.4 review, which is for your retake. Remember, you must have this entire worksheet completed, ready to go before I allow you to retake this test. So please follow along as we go through every type of problem, because these are the ones you're going to see on our retake test. Okay, here we go. The first question right here. We got to simplify these radicals. You saw it on the original test, and you're going to see it on the retake. You can only multiply numbers outside the radical together, and you can only multiply numbers underneath the radical together. So 2 times 3 gives me 6, and then 5 times 20 gives me the square root of 100. And I'm still not done. Now I need to simplify any radicals that I can. I'm not taking the square root of 6. There's no square root symbol. But I can take the square root of 100, which is 10. And remember, now that I've taken a square root, the square root symbol is gone. And now I multiply two numbers that are outside the radical together to get me the answer, which is 60. Okay, question 2. Square root of 30. I need to find a perfect square that's a factor of 30. Well, we just saw 100 as a perfect square, so let's use that one. Square root of 3 times square root of 100. So notice how the square root symbols are still both there because I have not taken a square root. I'm just splitting up the square root of 300 into two numbers that are factors of 300. Now, square root of 3 cannot be simplified, so I'll keep that right there. And the square root of 100 is 10. So I've taken a square root, so now the square root symbol is gone. That is the correct answer, but a lot of teachers like to see the coefficient out front, so I'm going to accept 10 times the square root of 3. Number 3, I have a numerator and denominator. So let's simplify the numerator first. Square root of 16 is 4. I know that's a perfect square, but I'm not taking the square root twice. I'm taking it once. So it's just 4. Then in the denominator, I need to split up 150. So a perfect square that I see as a factor of 150 is 25. So 25, and I think it's times 6. So I use 25 because that's a perfect square. And now I'm going to keep 4 in the numerator because it hasn't moved. And I'm just going to simplify the denominator. Square root of 25 is 5. I'm not taking the square root of 5 again. And then the square root of 6 because I have not taken a square root yet. Now if I look at this answer right here, 4 and 5, it's 4 divided by 5. It's not 4 times 5. It's division. A lot of you guys are giving me an answer that I 4 times 5, which is 20 root 6. That is not correct. Now for our types of answers, we need to have a rational number in the denominator. So I'm going to rationalize by multiplying by square root of 6 times square root of 6. So in my numerator, I get 4 root 6. In my denominator, I get 5 times, and square root of 6 times square root of 6 is the square root of 36, which simplifies to just 6. And now I can simplify that. 4 root 6 all over 30. And now, if you look at the two numbers, 4 divided by 30, there is a number that both goes into 4 and 30. That is 2. So 2 times 2 is 4. And if I divide 30 by 2, I get 15. So my final answer is 2 root 6 all over 15. Okay, let's start looking at some triangles here. So now these are all the different types of triangles you need to see. So here we go. First one. Notice how I have an altitude drawn, so that means I have to set up a proportion. So the proportion is set up like this. I'm going to use this small triangle right here, 3 and x, because I have two sides there. And I'm going to use my medium triangle, x and 9. But remember that I have to have x across from each other because it's part of both triangles. So I'm going to put x in the numerator here and 9 in the denominator. 3 times 9 gives me 27, and x times x is x squared. Now I square root both sides, but we never leave a square root of 27. We simplify. So a perfect square that's a factor of 27 is 9 times 3. I have not taken a square root yet, so it stays as a square root of 9 times square root of 3. And then I take the square root of 9, which is 3. The square root of 3 stays the same, and it equals x, so it's 3 root 3. Okay, question 2. This is the first time we have to use trig. Notice how this is an angle of 31 degrees. It's not an angle of 30, so we can't use our special right triangles. So here we go. I'm going to set up my opposites all based off of this angle. Opposite, adjacent, and hypotenuse. We're looking for side C. That's the hypotenuse. So I need to figure out which trig function deals with opposite and hypotenuse. So that's going to be sine. So for every trig question, we have to set up an equation. Sine of 31, because the angle goes in the parentheses, equals the side that was given to me over the hypotenuse that we don't know. And I need to solve for the hypotenuse. This is a tricky one. If I want to get this h by itself, I need to multiply both sides by h so that it cancels out here. And now I'm left with h times sine of 31 equals 5.12. And now I'm going to divide both sides by sine of 31. Because remember, sine of an angle is a number on your calculator. And now the sines of 31, so I have h by themselves. So now what I need to do is I need to take 5.12 and divide by sine of 30. So if I take sine of 31, that's about 0.52, and I'll take 5.12 and divide by 0.52, and I will get 9.85. So 9.85 units long. And that makes sense. It's greater because it's the hypotenuse. It's greater than 5.12. Okay, the next question. 45. Notice this 45, 45 right here. So that means I should use my 45, 45, 90. Okay, so the first thing you can do is across from the 45-degree angles are both A and A. They must be congruent. So once I find one of them, I can find the other. And across from the 90 is A times the square root of 2. A lot of you guys are taking 12 multiplying by square root of 2. I need to set them equal to each other. So I'm going to do my work out here. Times square root of 2, and then I'm going to divide by square root of 2 so I can get A by itself. So now I get 12 over root 2. Now I will give you some good credit for that, but I really want to rationalize the denominator. So if I do that, I'm going to multiply by square root of 2 over square root of 2, which gives me 12 root 2 over 2, because square root of 2 times square root of 2 is square root of 4, which simplifies to 2. And then 12 divided by 2 simplifies to 6, square root of 2. And because that's A, that means both my sides right here, x and y, are both A units long. So if I found A, then I have x and y. Question 7. I'm given two sides of a right triangle. I need to find the third one. Well, these are my legs, and my hypotenuse is always across from the 90, so that's my 21. So I have x squared plus 15 squared equals 21 squared. Let's put the little Pythagorean theorem here. Okay, so I need to solve for x. X squared plus 15 squared, that gives me 225. And then 21 squared gives me 441. And now I need to solve for x. So I get x squared, and I'm going to subtract 225 from both sides. So that's 216. Square root both sides. X equals, let's take a square root here. Ooh, it doesn't work out, so we need to find a perfect square that's a factor of 216. And let's divide by 4. Okay, what about 9? 4 worked, but maybe there's a bigger one. There is, okay. 216, let's divide by 36, see if that one works. It does. Okay, so 36 times 6 equals 216. So I have square root of 36 times square root of 6. Now I could do 4 and I could have done 9, but then I'd have a whole nother step to solve that simplification there. So I need to find the biggest perfect square, in this case 36. So if I solve that, simplify the square root of 36, which is 6, and the square root of 6 does not change, so that's my answer for x. Okay, number 8, 30, 60, 90. Okay, so now we need to look at our green sheet and go down to the 30, 60, 90 column. Across from the 30, which is this angle right here, is always going to be A. Across from the 60 is A times square root of 3. And across from the 90 is always 2A. Well, this is the only side I'm given here, so this is the only equation I can set up. 2A equals 15, which allows me to solve for A. Divide both sides by 2, divide both sides by 2, and I get A equals 15 over 2, or if you want to put 7.5, totally fine. And notice how I found A. That's what the side is across from the 30, which in this case is x. So A is 15 over 2, so that means x is 15 over 2. And if you look right here, y is A times the square root of 3. And if A is 15 over 2, that means y is just 15 over 2 times the square root of 3. So once you find A, you have all that information. Okay, last one, a little bit longer. Remember, you saw these types of problems, and you guys really got thrown off by them. Go one step at a time. Here we go. I'm given a 55-degree angle, which is tough, but it's not 30, 60, 90, so I have to use trig. So let's solve for y first. So here we go. I'm going to label my opposite, my adjacent, and my hypotenuse. And if you notice, I'm given adjacent, and I'm looking for the opposite, so I'm going to have to use tangent. So let's set up an equation here at the bottom. Tangent of the angle, which is 55, equals opposite, which is y, over 23. Okay, and I need to solve for y, so I'm going to multiply both sides by 23. So now it's 23 times tangent of 55. So here we go, 55 tangent gives me 1.428, so 1.43. And I'm going to multiply that by 23, and that gives me 32.89. So that's 32.89 when I solve for y. Good, so 32.89. And I can do the exact same thing if you'd like to solve for the hypotenuse. Or what I also saw was some people use Pythagorean theorem, which was great. So let's use a little trigonometry here. So I'm going to slide over to get some space. So I have my adjacent still, but now I'm solving for the hypotenuse. That's cosine. So cosine of 55 equals adjacent, which is 23, over x, which is the hypotenuse. This is just like that question we did earlier. I have to multiply both sides by x and then divide, so I get x times cosine of 55 equals 23, and then I have to divide by cosine of 55. Okay, so that gets x by itself. So it's 23 divided by cosine of 55. Well, cosine of 55 is 0.57, so now I'm going to take 23 and divide by 0.57, and I get 40.35. And you notice that's the greatest side out of 23 and 32.89 because it's the hypotenuse, so that makes sense. 40.35. And the last thing is the measure of angle t. Well, this one's the easiest, that's why I saved it for last. If this angle right here is 55 degrees, we know they have to add up to 90 because we also have the 90-degree angle. So 90 minus 55 is 35 degrees, and that's your last angle there. Okay, last question here on this page. Word problem. The perimeter of the square is 24. So if I draw a square here, I know they all have congruent sides, and 24 divided by 4 gives me 6. So each one is 6 centimeters long. Then it says find the length of the diagonal right here. If they are all 90-degree angles cut in half, then I have a 45, 45, 90 right triangle. And if I know that both the legs are a units long in a 45, and the hypotenuse is a root 2, that means that a equals 6, and I can just take that answer and plug it in right here. So the diagonal equals 6 root 2 centimeters. You could also use Pythagorean theorem, and you'd still get the same answer. Okay, on to page 2. A tree casts a shadow of 86 feet. Now, I saw a lot of people drawing pictures of this. I like that. Draw a picture, cast a shadow, which is on the ground of 86 feet. Find the height of the tree, so I'm going to label that as x. If the measure of the angle of sun rays to the ground is 32 degrees, so it's to the ground. And if this is the ground down here, and that's the shadow that's being created, or the ray, that means this is the angle with the ground. Okay, perfect. Round your answer to the nearest whole foot. Okay, so let's keep that in mind. So here we go. Let's label opposite adjacent hypotenuse. Because this is not exactly 30, we cannot use our 30, 60, 90. So here we go. We got O. Let me change it up a little bit. O, adjacent, and hypotenuse. Well, I don't know anything about the hypotenuse out here, but I do know that I'm solving for the opposite and I'm given the adjacent. So we have to use tangent. So I'm going to use tangent always of the angle equals the opposite, which is x, over the adjacent, which is 86. Well, this one's an easy solve because I just need to multiply both sides by 86. And then whatever that gets me for x, we have our answer here. So I'm going to find tangent of 32 first, which is about 0.62. So 0.62 times 86, which gives me 53.32. It says to the nearest foot, so I'm going to say about 53 approximately. So those squiggly lines are for approximately 53 feet. Awesome. Last question, or last word problem here. A 32-foot tree. Okay, so if you want to draw a little picture, you absolutely can. 32 feet casts a 70-foot shadow. Okay, good. And a nearby building, tall building, casts a shadow of 114 feet. How tall is the building? So we label that x. And if you notice, now we have two sides of two right triangles. Right, you don't have to draw the right triangles because we're not actually solving for the third side in either one of them. What we are solving for is trying to set up a proportion. Because what we have here is that the triangles are similar because they're using the exact same sun's ray. So they must have at least two congruent angles. So that means they're similar, so we can set up a proportion. So I'm going to go over here. Height over shadow equals height over shadow. So let me get a little space over here to the left, or to the right. And I get 32 over 70 equals, let me get some space, equals x over 114. Now we can just cross multiply and solve. So 32 times 114 is 3,648, and then 70 times x is just 70x. And now we divide by 70, divide by 70, divide by 70, because I really want to solve for that height, and I get 52.11 feet equals x. And you know, it does make sense because this is bigger than 32. And that's good because the shadow from the tree was only 40 feet, and the shadow from the building was a whole 114. Okay, here we go. down to these proportions, which you guys all can do, and yet we still struggle setting them up. So we got to show some work here. The people that are losing points are the ones that don't want to show all their work. So I'm going to cross multiply here, and I get 2 times 6x minus 3, and equals, not divided by, 5 times 2x plus 3. Now this step you guys can all solve, but you got to set it up. Take the second to do so. Distribute, I get 12x minus 6. Distribute the 5, I get 10x plus 15. Let's move the x's to one side, so I'm going to subtract 10x. So I get 2x minus 6 equals 15. Let me just erase that little piece right there. Okay, and now I'm going to add 6, so I get 2x equals 21. Divide by 2, I get x equals 21 over 2. Okay. Let me just erase a little part of there. Good. 21 over 2. Okay. Question number 14. Cross multiply again. X times x is not 2x. That's x plus x. It's x squared. And 18 times 8 gives me 144. Square root both sides. And now, this is not a geometry problem. So x does not stand for a side length. It stands for just an x, any number in an algebraic equation, positive or negative. So if I take the square root of 144, I get plus or minus, because it could be positive or negative, 12. Right? If x stood for a side length or an angle measure, then we could not have a negative angle. But in this case, we can, because it's not an angle. It's just a number. Okay, these two problems kind of cause some of us some issues here. So here we go. If quadrilateral ABCD is similar to quadrilateral WXYZ, then blank over blank equals blank over blank. Remember that the order of the letters matters. Okay, so first and first, second, second, and so forth. So AB is the first two letters, WX are the first two letters. Good, that makes sense. Now we don't know what goes in this numerator here, but we know that XY are the middle two letters, so the middle two letters have to go in that part of the proportion. Okay, because side lengths are in the same position. Now let's go here. Same idea, but now we're dealing with triangles. So we have to set up a proportion, because if you look, I'm given two sides from ABC, and I need to find another from DEF. So AB is similar, or is corresponding to DE, because they're the first two. So I'm going to go 6 over 18. And then BC are the second two letters, and they are corresponding to EF. So I'm going to go 10 over, let's just call it X. Okay, so I put them in position, because if you look right here, AB is corresponding to DE, and BC is corresponding to EF. Okay, so now I can cross multiply. 6x equals 10 times 18, which is 180. Divide by 6, x equals 30. There we go. Almost done here, guys. We got 3 more questions, all similar triangles. Determine the value of x in the following questions. Okay, here we go. Big triangle to small triangle equals big triangle to small triangle. If you notice, 4 is not an entire side of the big triangle, so I need to actually find the entire side of the big triangle, in this case 14. So now my proportion is big triangle, which is 28, to its corresponding side x of the small triangle, and big side of the big triangle 14 over its corresponding side 10. Cross multiply. 280 equals 14x. Divide 280 by 14, and we get 20. There we go. Okay, we got 2 more questions here. Proportion. Now, here's the tricky part. This is a little different than the problem we just did, because if you look, 3 is a part of a side, and so is 9. They are corresponding parts. Where the last time we tried to set up 4 and 28, where 4 was a part of a side and 28 was an entire side. So in this case, we don't have to add up 12 and 9 to get this whole side length, because we don't know the entire side length over here. So we have to find corresponding parts. So in this case, I can just go from top of the triangle over bottom of the triangle. These 2 parts equal top of the triangle over the bottom of the triangle. These 2 parts. Cross multiply. 9x equals 36, which is 3 times 12. Divide by 9, x equals 4. There you go. Okay, last one. Here we go. I'm going to compare these two triangles. They are similar because of the two corresponding angles by angle similarity. I'm going to work outside of the triangle to inside of the triangle equals outside of the triangle to inside of the triangle. So 14 over x, outside to inside, equals outside to inside. Okay, and then I'm going to cross multiply. So 14 times 12 equals 168, and then equals 8x. Divide 168 by 8, and I get x equals 21. There we go, guys. So now you've seen the entire worksheet. We have this worksheet and the one before. A little bit of similarity, a lot of right triangle trig. Make sure you focus on that first page because that's what gave us a lot of issues. You guys got this. This is all you're going to see. Good luck.